This is problem 3.6.34. In this problem, we're trying to differentiate the function y equals tangent of 3x divided by x plus 7 quantity to the fourth power. In order to do this, we're going to need to use a combination of the chain rule and the quotient rule. Let's begin by using the quotient rule. This function is clearly recognizable as of the form u over v. So we know that our u for the quotient rule is simply our numerator, which is tangent ex, and our v is simply our denominator, x plus 7 to the fourth. But we don't quite know yet what our u prime and our v prime are. In order to find them out, we're going to need to use the chain rule. So let's start by finding u prime. First, we need to break your u down into two component functions. F of u, which we're going to set equal to tangent u, and g of x, which we're going to set equal to 3x. So now we can go about finding f of prime of g of x and g prime of x. So first, let's find f prime of u. F prime of u is simply the derivative of tangent u, which is secant squared u. So f prime of g of x, we just substitute g of x, which is 3x, in for u, and we get secant squared 3x. G prime of x is simply the derivative of g of x, which is 3. So we can write u prime as f prime of g of x, which is secant squared 3x, times g prime of x, which is 3. So I'm going to write this up here. Our u prime is equal to 3 secant squared of 3x. I'm going to erase all this work. So now let's go through the same steps to find out what our v prime is. So before we begin, we're going to need to break our v down into two component functions. F of u, which is equal to u to the fourth, and g of x, which is equal to x plus 7. So now we need to find f prime of g of x. So we need f prime of u, which is the derivative of u to the fourth, which is 4 u to the third. So then we know f prime of g of x is substituting in g of x, which is x plus 7 for u. We get 4 x plus 7 to the third. So now we need to find our g prime of x, which is simply the derivative of g of x, which in this case is 1. So we know that v prime is equal to f prime of g of x, which is 4 x plus 7 to the third, times g prime of x, which is 1. So I'm going to write that up here. 4x plus 7 to the third. And now I'm going to erase all this work. Okay, so now we have everything that we need to use the quotient rule. So the quotient rule tells us dy dx of our original function up here is going to be equal to v, which is x plus 7 to the fourth, times u prime, which is 3 secant squared 3x, minus u, which is tangent 3x, times v prime, which is 4 x plus 7 to the third, all over v squared, which is x plus 7 to the fourth squared. So now technically we could stop here, but we're going to try and make this look a little nicer. We can pull out x plus 7 to the third, x plus 7 to the third, times x plus 7, 3 secant squared 3x, minus tangent 3x times 4 over x plus 7 to the fourth, but this whole thing is squared, so with 4 times 2 we have to the 8th. So now we can factor this out, and this is going to reduce to a 5, and we'll be left with dy dx is equal to x plus 7 secant squared 3x times 3, I'm just going to put that in the front, minus 4 tangent 3x all over x plus 7 to the 5th.